Here are the answers for the section 6-5 word problems assignment. Number 1, a pilot coming out of a dive at this velocity experiences a centrifugal force of this many pounds. If centrifugal force is proportional to the square of the velocity, find the force flying at this velocity. Let's create an equation between variables for centrifugal force and velocity. For force, I'm going to choose the letter F. And for velocity, I'll choose the letter V. And the sentence that says that force is proportional to the square of the velocity, we can write like this. Force equals some number times velocity squared. Let's figure out our value of m by using the information given in the first sentence. The pilot experiences a force of 1,800 pounds, so fill that in for the letter F, when the velocity is 600 feet per second. Fill 600 in for V. By filling in those variables, we're only left with the letter m, and therefore we can solve for m. We get m equals 1,800 divided by 600 squared. That value turns out to be 0.005 on a calculator. Now that we know the answer for m, let's rewrite that original equation that relates F and V. Force equals 0.005 times V squared. Now let's go to the very last sentence where it asks us to find the force, to find the value of F when the velocity is 1,000. Let's fill in 1,000 for the letter V. And evaluate that answer on a calculator. And the answer is 5,000. Now the letter F was representing centrifugal force, and we can see that in the problem where force was mentioned earlier, that the unit of measure was pounds. Next, number 3. The energy of a 2-pound satellite orbiting at this speed is equivalent to 27,000 British thermal units of heat, or BTUs of heat. If the amount of heat varies directly as the square of the velocity, find the heat equivalent of energy at this orbital speed. The variables are heat and square of the velocity. Let's make an equation with those two variables. For heat, I'm going to choose the letter H. And for velocity, I'll choose the letter V. So the sentence that says heat varies directly as the square of the velocity can be written as H equals m times V squared, where m is some number that we have to figure out. Now in the very first sentence, it gives us a value for heat, 27,000 BTUs of heat, and it gives us a velocity, 17,500 miles per hour. Let's make those substitutions. The 27,000 is our value of H, and the 17,500 is our velocity. Let's solve this for m on a calculator. We'll go 27,000 divided by 17,500 squared. And the result turns out to be a very small number, 0.0000881. There's actually some additional digits there, which I'm going to keep in my calculator's memory. Now that we know the value of m, let's rewrite our equation that relates H and V. Again, the value of m actually has more digits than what I'm writing down. Now let's go to the last sentence in the problem, and it says, find the heat if the satellite orbits at this velocity. So let's make that substitution in place of V. To get H, I have to take this value of m, which is still on my calculator screen, and multiply it by 25,000 squared. So that number's on the screen right now. I'm just going to press times and then 25,000 squared. The result for H is 55,102. H was measuring heat in British thermal units, or BTUs. Next, number 5. The strength of a horizontal beam with rectangular cross-section and a fixed width and length varies as the square of the thickness. If a thickness of 6 inches is required to support a weight of 5,400 pounds, then how thick should the beam be to support a weight of 8,000 pounds? So it's talking about a square beam. So if we were to draw a picture of the beam, it would look like this. Imagine this is a picture of a right rectangular prism, our beam. There was a sentence in the paragraph that we can use to model the relationship between the thickness of the beam and how much weight it can support. So let's choose variables to represent that. Thickness, I'm going to choose the letter T. And then the weight that the beam can support, I'm going to choose the letter W. We're told that the strength of the beam, or another way to think of that, the weight that it can support, varies as the square of the thickness. So m times t squared. In the next sentence, we're given values for thickness and for weight. Let's make those substitutions. The weight of 5,400 pounds is associated with a thickness of 6 inches. Let's solve this for m. 5,400 divided by 6 squared. That makes 150. Now that we know our rate of proportionality, let's rewrite the equation with that number in place of m. The very last sentence asks, how thick should the beam be to support a weight of 8,000 pounds? Let's substitute 8,000 in place of w and solve it for t. Let's divide both sides by 150. Now we have 53.3 is equal to t squared. Now let's take the square root of both sides, and we get 7.3 is equal to t. T was measuring thickness, and when thickness was mentioned in one of the sentences, it was mentioned in inches. So our thickness is 7.3 inches. Next, let's go to page 228, the oral problems. In number 2, we have a function definition, f of x equals 1/3 times x squared. We're asked if that's quadratic. The highest degree in that function rule is degree 2. So yes, that is quadratic. Is it symmetric with respect to the y-axis? The function has only the x squared term, no x term. So yes, that is symmetric with respect to the y-axis. In number 19, we're given a little bit different function rule, and we're asked to find f of 0. That's when you substitute 0 in place of x. The result turns out to be 0. Now, page 229 written, we're asked to make 2 graphs on the grid. Here's the first one, here's the second one. They only differ by sign. The value of a is positive 2/3. This one over here, the value of a is negative 2/3. Let's make an XY table to find some dots to graph. As the center row of my XY table, I want to locate the vertex. Because this equation has only an x squared term and no other terms, the vertex will be 0, 0. We're going to get some parabolas in a different section where the vertex is another point, not 0, 0. The next thing to do is find points to the left and to the right of 0, 0. We can choose numbers for x that go to the left of 0 and choose corresponding numbers that go to the right of 0. Now let's make those substitutions to find y. I'm going to begin with the 1. 1 squared is 1, and 2/3 times 1 is 2/3. This result here will also be 2/3. Now I'm going to substitute 2. 2 squared is 4, and 2/3 times 4 is 8/3. 8/3 is the same as 2 and 2/3. This number up here would end up being 2 and 2/3. Now we can graph that parabola. Here's 0, 0. Here's negative 1, comma 2/3, and positive 1, comma 2/3. And here's 2, comma 2 2/3, and positive 2, comma 2 2/3. Here's the first parabola. Now this other parabola differs only by that minus sign. Think about what that would have done to our y values when we made our table. They would have made these y values negative. So the other parabola will still have a dot at 0, 0, but one of its points would be negative 1, negative 2/3, and positive 1, negative 2/3. And another point would be at negative 2, negative 2 2/3, and positive 2, negative 2 2/3. Let's graph this parabola in. Notice that it is the reflection of our first parabola over the x-axis. One parabola opens up, the one that had the positive a value. The other parabola opens down, the one that had the negative a value. Next, number 9, g of x equals negative 4 times x squared. Is this ordered pair a solution or a root of that? Well, let's find out. Let's replace g of x with 1. When we replace x with negative 4, does negative 4 times negative 4 squared make 1? No, it doesn't. What about this? Is this a solution? Let's find out. Let's replace g of x with 4 when we replace x with negative 1. Is negative 4 times negative 1 squared equal to positive 4? No, it's not. This solution is not on that graph either. Number 15, we're given this general formula for a quadratic equation. And we're asked to find a if this is the value of x and this is the value of y. Let's make the substitutions. In place of y, put in negative 1/8. And in place of x, put in negative 1/2. Now let's solve the equation till we find a. Negative 1/2 squared makes positive 1/4. Now let's multiply both sides by 4 to cancel away the 1/4. We get negative 4/8 is equal to a. This reduces to negative 1/2. Number 23, if s varies directly as r squared and r is proportional to t, what happens to s when t is doubled? Let's first figure out what happens to r when t is doubled. Because r is proportional to t, if t is doubled, then so is r. Now what happens to s if r is doubled? Because s varies directly as r squared, if r is doubled, then s is quadrupled. That means s is multiplied by 4. Page 211, orals. We're given this set of ordered pairs, and we're asked for the domain and range. The domain is a list of the x values. This is an x value, this is x, and this is x. Let's simply list them. The range is a list of the y values. This number is a y value, this is a y, and this is a y. We simply need to list them. Number 10, here we have an equation with y and x. We're asked for the domain. In general, the domain of equations is all real numbers. But sometimes there are exceptions, excluded values. We called them restrictions in an earlier section. Let's decide if there are any restrictions when we have a fraction such as this. This fraction has the variable x in the denominator. We know that we don't want a fraction to have a denominator of 0. So is there any number for x that if you used it, it would make this turn out to be 0? That number would be negative 2, because negative 2 plus 2 makes 0, and the absolute value of 0 is 0. So our domain is all real numbers, except 0. A fast way to say this is x cannot equal 0. And that's how we showed this in an earlier chapter, and we called it a restriction. Number 12, r is less than this fraction. Again, our concern with fractions is if there's a variable in the denominator, we don't want the denominator to turn out to be 0. So are there any numbers that we should not use for k, because doing so would create zeros down there? I think we would find that k can be all real numbers except -7 or +2. Page 214, orals. We have this drawing of a relation. We're asked if it's a function. When you have a graph, a way to tell if it is a function is to see if any place along the graph lines up vertically with another piece of the graph. In this case, there is such a spot. When x is 0, that is right along the y-axis, there's a dot with a value of -3, and there's a dot with a y value of +3. So when x is 0, y has two different values. That's not a function when that happens. Number 8, is this a function? Yes, it is. There is not any place on the graph where there's vertical overlap with another piece of the graph. Now, what's the domain? We see that we have dots on this ray to the left of 0. So that means that x could be less than 0. Or, looking at the other ray, every one of the dots that actually make this ray have x values that are greater than 0. So x is greater than 0. The one value for x that's not in the domain is 0 itself, because there is an open dot here at the origin. Now, what's the range? This is your y values. Let's make statements describing the y values. I think all the y values on either ray are numbers that are less than 0. Next, page 219, oral. The perimeter P of a square varies directly as side length S. We're asked to write an equation for that. P equals some number m times side length S. And in the directions, we're told that the value of m is either given in the problem or it's known to us based on the context. In this problem, we know the value of m is 4. The perimeter of a square is equal to 4 times the side length. Number 4, the distance d that an object travels at speed 12 miles per hour is directly proportional to time t. So distance equals some number times t. And the value of m is given to us in the problem. It's the 12. So distance equals 12 times t. Number 6, the income I on an investment at this % interest rate varies directly as the principal P. So I equals m times P. And the value of m is given in the problem. We're told the amount of interest you earn is 6% of P. And here's our equation. Number 12, here are some ordered pairs representing points on an XY coordinate grid. If we were to graph those dots, would they line up in a straight line? We're asked if this is linear. They will line up in a straight line if there's a constant rate of change between them. So let's find the rate of change. When x is changing by 1, y is changing by 4. That rate of change between y and x is 4 over 1. When it changes by 1 unit, this one changes by 4. Still 4 over 1. And from here to here it changes by 1 unit, and from here to here it changes by 4. That's still 4 to 1. There is a constant rate of change, so we're going to say yes, it's linear, and our slope is 4 to 1, or simply 4. Number 14, same question. When x is changing by 1 unit, y is increasing by 6 units. The rate of change between y and x, between those two dots, is 6 to 1. Now between here, this changes by 1 and this changes by 6. Same rate of change. From here to here, this is changing by 1 unit. This is changing by 3. That's not the same rate of change. This is not linear. Those dots do not line up in a straight line.